Hi, so now I want to do a example on the multivariate delta method. So multivariate delta method example, and I'm going to do 5.16 from the textbook. So just going to write down what the problem is asking. So we are given that x11, x21, x12, x22, up to x1n, x2n are IID random vectors, right? And they have a mean, which is equal to mu1, mu2, that vector, and covariance matrix is equal to sigma, right? Now, the problem states, and this makes intuitive sense, that x1 bar is equal to 1 over n times the sum of all of the x1's, x1i's, and x2 bar is 1 over n times the sum of all of the x2i's, right? And now, by the problem states, so by definition, given in the problem, we have that y sub n is equal to x1 bar times x2 bar. x1 bar from over there, x2 bar from over there. Right? So y sub n is equal to g of x sub 1 and x sub 2, right? Because it is a function of x1 bar and x2 bar. So we have by the CLT that the square root of n times x1 bar, x2 bar, so this vector minus the mean vectors, so the mean of each one of those, converges in distribution to multivariate normal distribution with mean vector 0 and covariance matrix of sigma, right? You should watch video 1 in this series if you want to see why that's the case or see that worked out. Now we have that the gradient of g is equal to, by definition, the partial g with respect to which in our case we have S1 is equal to x bar 1 and S2 is equal to x bar 2. Right, so this is equal to, what's the partial derivative of g with respect to x bar 1? Well, we have that g of x bar 1, x bar 2 is equal to x bar 1 times x bar 2. So if you take the derivative with respect to that, then you're left with x bar 2. And similarly, by symmetry, you have the partial of g with respect to x bar 2 is equal to x bar 1, right? So this gradient is equal to, we have x bar 2, x bar 1, right? So the delta method which I'm gonna rewrite for the multivariate state here, is square root of n times, trying to remember it, y sub n minus, or g of y sub n minus g of mu, there we go, converges in distribution to our normal mean zero variance gradient at u transpose sigma gradient at mu, right? So this is the multivariate delta method. Then, for our case, we have the square root of n, g of yn, here is equal to x1, x bar 1, x bar 2, minus g for mu, which is mu1, mu2, plugging mu, the vector mu in to g. This converges in distribution to normal random variable with mean equal to 0, and variance is gradient at mu transpose sigma gradient at mu. So we have gradient at mu transpose is equal to the transpose of, trying to see, we have it written right here, but instead of x bars we have mu, so we have mu2, mu1. We have the covariance matrix, which isn't actually given in the problem, which is kind of funny, but yeah. And we have the gradients vector, which is mu2, mu1. So if you take just gonna do some linear algebra quickly. It's gonna get us, I'm gonna skip the work, but we have mu2 squared sigma 1 1 plus 2 mu 1 mu 2 sigma 1 2 plus mu 1 squared sigma 2 2. So we have square root of n x bar 1 x bar 2 minus mu 1 mu 2 converges in distribution to normal mean 0, and variance is equal to thinking